Hello, hello, hello. Good morning. Morning, Sierra. So you guys remember that I said to cross off 16, right? Okay, cool. How's Mr. Peoples' thing yesterday? Oh, that's good. Who are the last two people to come in right now? Nice picture. Does that mean that the other person is Mike Felber? So I like to hear. All right, so you guys want to start? Do you want to start with 14? I don't know if you guys saw what we did for 13 at the end. We were like finishing it up at the end last time, or if you guys want to go back and watch it if you weren't there. Okay, start with 14. I'll put 13 up again. That's the work, just in case you guys want to see it. That's all for 13. So I think this right here, this is the overall area. Like that's the overall answer. We did the area of the big circle minus the area of the pentagon inside. So it was like 64 pi minus with some weird decimal. And then that should be the answer. We had to do like two trig equations though, or I guess one trig equation and then one Pythagorean theorem. It's usually how it works. You got to set up a trig equation once to get, one of the sides, and then once you have two, then you can do the Pythagorean theorem if you want to get the third. So the only reason I'm going over that is because we're going to do the exact same thing right now for number 14. Okay, so they give us in 14. What's the radius in 14? Somebody type it in. See if I can find a whiteboard marker. Okay, so I'm gonna do it on a whiteboard because I'm out of room on the paper. So number 14, look at number 14 now if you guys have it, and tell me what the radius is. Oh my gosh, are you kidding me? 10, yes, it's 10. Okay, hold that thought. All right. I think I have one of these two markers has to work. Okay, so radius is 10. So remember, like on the other one, in the end, what we're going for first, we know how to find the area. Okay, so let's figure it out right now. If the radius is 10, do it on your own and just type in what's going to be the area of that overall circle. Talk about area, pi r squared. So we want the radius of the overall circle. Forget about the shape inside. Radius is 10. What's the area? Pi r squared. Um, 100 pi 100 times 314. Yes. Yes, exactly. Hello, Amy. I just want to make sure everyone understands that it's the same as 100 pi, because when you get to next year, you're going to be doing doing a bunch of equations with a pi in it. So like you're going to have like pi, the symbol in your equations, kind of like we did yesterday where we were solving it for r with the areas of a sector and the length of a sector and stuff. So just get used to the pi, but yes, either they're both the same thing. Okay, so for this one now, what I did is I took one of those triangles. Remember, we're going to make a bunch of equal triangles, and there's going to be 8 of them for number 14. Okay, so if I can find the area of one of those triangles and multiply it by 8, that's going to be the area of the octagon on the inside. Okay, so we have to think now, what do I need to know to find the area of a triangle? Area of a triangle, exactly, half the base times height. So we need the base of the triangle, which we don't have, and we need the height of the triangle, which we don't have. Exactly. So now to figure out what the base and the height are, we need to divide one of those 8 triangles up to make 2 equivalent right triangles. So now what I did is I drew a line down the middle, and then, ignoring this side, I blew this triangle up, one of them. Okay, the height of it, that's our h. That's one of the things we're looking for. And then the base of this one would technically be half of the base of what we're actually looking for. Okay, so now we have a right triangle. Down here. So we should immediately be thinking sine, cosine, tangent, or Pythagorean theorem. Okay, now the only way we could do Pythagorean theorem, how many sides? Somebody type this in, see if we understand this. How many sides of this triangle would we need to know to be able to use the Pythagorean theorem? Like how many sides would have to be given to us for us to use the Pythagorean theorem? Exactly. So that tells me now it's not Pythagorean theorem. It has to be sine, cosine, or tangent. Okay, so I'm going to just find the h first. Okay, but remember, we need one of these angles. Okay, so in the beginning, we knew that there were, let me show you the picture. We figured out up here, there were 8 of these triangles, these equivalent triangles in the middle. Okay, so does anybody remember how we find one of those 8 equal angles around the middle? Let me do it on the picture that you guys have. Yes, Amy. So going back to our picture, I drew in the 8 little equivalent triangles, meaning there'd be 8 congruent angles. No, you're right, Amy. 360 divided by 8. So 45. So now, remember, this one here, so this is what we just figured out. If that one there is going to be 45, then when we split it in half, what's this one going to be? So now we have an angle we can stand on here. And keep in mind this H, this is adjacent, and 10 is the hypotenuse. So does anybody remember which of the three ratios we use for adjacent and hypotenuse? Adjacent and hypotenuse. It's got to be sine, cosine, or tangent. Cosine. So that means we're going to set up our equations, going to say cosine of 22.5 equals the adjacent over the hypotenuse. So cosine 22.5 equals, and then remember the side that's adjacent to 22.5 is the side next to it. So that would be the H, adjacent over the hypotenuse. We know the hypotenuse is 10, so the 10 goes on bottom. So this is the trigonometric equation that we just set up. Trig, because it has a cosine in it. Anything with sine, cosine, or tangent makes it automatically trig. Equation, because it has an equal sign. Okay, and now we're looking for H. So how do we get rid of the 10 underneath it? What do we have to do to both sides? Yep, multiply by the bottom. So multiply both sides by 10. So we got 10 times the cosine of 22.5. Yes. Make sure you're in degrees. 10 times cosine 22.5. Go ahead and let me know when someone gets it. That's what I got. I got 9.24. So remember, you might be in radians, Jimena. Make sure it's in degrees if you click on the wrench in Desmos. So here's my, I did times 10 over here, times 10 over here. So those 10s canceled. And then here was it's not exactly in a row, 10 times cosine of 22.5. I should be 9.2. Try it again, Jimena. See does that make sense? Oh, that's why. So here, I'll walk you through it on your phone because honestly, I'll show you how to do it on your phone. Okay. So on your phone, okay, you got to turn it sideways. You hit 22.5 first, and then you hit the cosine button. Okay, then you're going to get this. 25 or 22.5, then the cosine button, you're going to get that. And then you have to hit times 10. And then you have to hit equals. It doesn't make any sense. You do it pretty much completely backwards. And that's the only reason I try to make you guys use Desmos on this. Your phones will work, they're just dumb. Okay, so is everybody good with the height? Is everybody okay with this? So now we know that the height, the dotted line right there. Yes, exactly. Exactly. So what your calculator did, Jimena, was 10 times 22.5. And so it just made it 225. Okay, so the height's 9.24. So now we have this. All we need now for our area formula is the base. Okay, so we have this is 9.2. Let's go with 9.2. That's fine. So we go x squared, because we don't know the base, plus 9.24 or 9.2 squared equals 10 squared. So I'm going to get another whiteboard. So we got, and this is for the base, remember? So we got dealing with now. We know the height. We know this angle, which we're actually not even going to need it right now. Oops. We know that angle too. Now all we need is this. So now going back to what Xavier was saying earlier, all you guys were saying is that when we have two sides, we can use the Pythagorean theorem. So x squared plus 9.2 squared equals 10 squared. .2 squared. So this is what I got right here after my first line. X squared plus, I think it's 84.64, and then should be equal to 100. So then we have to subtract the 84.64. $15.36. So when we subtract the 84.64, I got that. And then always, whenever you're solving the Pythagorean theorem, you always have to square root at the end. So we're going to be, somebody tell me what you get when you get it. Beautiful. So now, this is what we did first. Remember, that was the height. And then with that one, it gave us the base of this triangle. But remember, that was half the base of the original triangle. So before we do the formula, remember it's half the base times height. So we could either double this and then plug it into the formula, or it's basically just this times this. Do you guys see that? The formula was half the base times the height, but this, what we just got, is actually half of the base. So it's basically just 3.9 times 9.2. And that's going to be the area of one of those triangles. Okay, so let me get another board. So now we know that area is for a triangle is equal to half the base times the height. And then the other one was 3.9. Okay, so remember, oh dang, you're way ahead of me. Let me figure it out. Yes, that should be right. That's close enough, Jimena. It should have been this, Jimena, if you did that. Remember, area should be half the base times height, but we figured out that half of the base was 3.9. So half the base times height is basically 3.9 times 9.2. But if you use different numbers, oh yeah, yes, exactly. Okay, so now that 35.88, remember, that's the area of one of those 8 triangles. So now we have to multiply that by 8. So 35.88 times 8 is so when you multiply that by 8, you should get something like that. Because remember, we wanted the area of the whole thing, which is 8 of those triangles. So we had to break that whole thing into 8 triangles. Then we had to break one of those 8 triangles into 2 triangles, and then go all the way backwards. Okay, so now the very last thing we need to do is the area of the overall circle, which you guys told me at the very beginning, I think was 314.12. And then we have to subtract that from the area of the octagon inside of the circle, which we just found was 287.04. So we got to subtract those two things, and that's going to give us the leftover area of the dark shaded region. Yep. The area of the shaded should be about 27.08. Questions? Take a look at it right now. So 15. So while I'm erasing all these stupid boards, if you're looking at 15, okay, what's the area of the big circle? Okay, because we're gonna have to subtract. We're gonna have to do that minus the area of the rectangle. So what's the area of that big circle? That should be the easiest part. You got it. 25 pi. Okay. So the area of the big circle is 25 pi. Okay, so now how are we going to find, what do we need to know now? What's the formula to find the area of the rectangle inside of the circle? How do we find the area of a rectangle? Yep. Okay, so we got the area of the circle is 25 pi. We know what the formula of a rectangle is, length times width. Yep. Do we know either of the length or the width? Do we know one of those from the picture? What is it? It really doesn't matter if you consider the length or the width. You know what I mean? Because we're going to be multiplying. So like 5 times 6 is the same as 6 times 5. So exactly. So one of these numbers is 5. Okay, so we'll call it width. What's wrong, Zeus? So I'm going to sub that in. Now, we know that the area of a rectangle is whatever the length of this one is times 5. So to solve this problem, all we really need to find is the length of the rectangle, the other dimension. So tell me if this makes sense to you guys. And then we know this. We know that, oh shoot. So we know this distance is 5. We don't know for sure. We don't know for sure. Doubled would be 10, but remember, if you double it like that, it would have to go right through the center. So like right here, if we went from here all the way through this way, then that would be 10. Or if we went like here through here this way, like from basically like edge of circle to edge of circle and passing through the middle, that would be 10 every time on the circle. Basically the diameter. Does that make sense? Okay. So what we need to do is we basically need to find this distance here, which is this question mark, and then just double it. Does that make sense? This question mark here, you know, if we zoom in and make this a bigger triangle, this is going to be half of the length of the rectangle. This would be the length, the thing we're looking for. This would be half of it. So if we stand on 60, good, Amy. Sine because we're looking for the opposite, and we have the hypotenuse. So opposite, hypotenuse, opposite, hypotenuse. that would be sine. Does that make sense? So if we multiply both sides by 5, the question mark should be equal to 5 times the sine of 60. So did we get something like this? Okay, so now remember, to get the actual length, we have to double that, because 4.3 is only this distance here. So it's going to be 8.6 is going to be the length. So now going back to our formula, the area for this rectangle is going to be now 8.6 times 5. So we got to do 25 pi minus whatever that comes out to. So 25 pi minus yes, that's 43. So 25 pi minus 43. I think it should be a 4 because it's 0.539. So the 3 goes up to a 4. But you would have gotten it right on a test. I mean, yeah. 83.3. I think that sounds right. Is that what we got, guys? can't remember now. I erased all the boards and I didn't write it on my paper. Oh, okay. Yeah, it was 27.08. Yeah, just rewatch it whenever you get a chance. And like I'm leaving all the assignments open so you can turn them in like till the end of the year. So like they're gonna say that they're due, but like you have time. Like it's not gonna be late. So um just rewatch the live, and if you don't get it, just email me, and like I'll do a live thing, and it could just be me and you. Yeah, just email me. Always email me. Yeah, 16. Still submitted picture. No, if I already put your guys' grade in, you don't have to submit anything. I trust you. Yeah, because I think I put all of your guys' grades, the same people that were here last time, pretty much, minus a few. No, I think you're good, right? Let me check Power School, Xavier. Oh shoot, I might have forgotten you, Xavier. No? Let me see. Yeah, Cameron. No, yours is in, Xavier. You just have to make sure you come visit. Oh, and when you guys make sure when you guys are being make sure guys when you guys are trying to be TA, you request me. And I can still help you with Math 3. We still need to figure out a way to have some kind of a party too for the end of the year. We might have to meet at Pizza Plus or something. Oh, that's a great idea. Not if it was a really good quote. I'm looking at quotes right now. All right, guys. You guys have a good day. Thinking about going to do some math in the garden today. All right, guys. Have a good day. Email me if you have questions. The next live will be on Thursday next week, Thursday at 10 again. I actually want one sooner than that. Just email me. All right. Thanks, everybody.